Welcome back to D-Machine. In our everyday lives, few objects work harder and receive less appreciation than the humble AA battery. These small metal cylinders power radios in old workshops, flashlights in quiet cabins, and the toys and tools that fill our homes. Yet, behind their simplicity lies a complex and carefully engineered process that turns raw steel and mineral powder into a dependable source of energy. Today, we step inside a real factory in China to see how millions of batteries are produced with speed, precision, and remarkable craftsmanship. So sit back, relax, and join us as we follow the full journey from empty steel shells to finished power cells. Our journey begins with a massive coil of cold-rolled steel, unwinding slowly as it feeds into a high-tonnage press. This steel strip will become the outer shell of every AA battery, a structure that must be both lightweight and incredibly strong. As the sheet slides under the stamping dies, each precise strike forms a small, cup-shaped shell in a single, rapid motion. Thousands of these tiny steel cups roll out onto the conveyor like silver coins pouring from a machine. Workers collect them into large bins, ready for further shaping and inspection. These humble cups are more than simple containers. They will serve as the battery's negative terminal and the foundation for everything that comes next. After the steel cups are stamped, they move into the deep drawing section, one of the most critical stages in shaping the battery's body. Workers load bins of metal cups into an automatic feeder, which arranges them neatly and lifts them onto a narrow rail. One by one, each cup enters a multi-stage drawing machine, where a series of hardened steel punches stretch the walls taller and thinner with remarkable precision. The transformation happens in just seconds. A shallow cup becomes a long, seamless cylinder, perfectly sized for an AA battery. Excess metal is trimmed away, the edges are smoothed, and the newly formed battery can slides down the conveyor for inspection. From a simple coin-shaped shell, the battery now begins to take on its familiar form. Once the steel cans have been fully drawn and trimmed, they move into the coating section, an essential step for every alkaline battery. Workers feed thousands of empty cans into an automatic conveyor, where they are aligned and guided into a compact but powerful coating machine. Inside, a rotating brush and a spray system apply a thin layer of carbon-based coating to the interior walls. This black conductive film may seem insignificant, but it plays a critical role. It reduces internal resistance, improves current flow, and helps the battery deliver stable power over its lifetime. As the cans spin rapidly, the coating spreads evenly from top to bottom. Excess material is removed, and the cans continue their journey through drying tunnels and inspection trays. By the end of this stage, each can is electrically prepared for the chemical core that will soon be added. With the steel cans prepared, attention now shifts to one of the smallest yet most important components of an alkaline battery, the bottom seal assembly. In large vibrating feeders, thousands of metal end caps, collector pins, and plastic sealing rings are sorted and aligned. Each part has a precise role. The metal cap forms the negative terminal, while the long, needle-like collector pin carries electrical current from the internal chemical core to the outside circuit. On a fast-rotating carousel, robotic heads pick up the components and weld them together with pinpoint accuracy. The collector pin is inserted, the seal ring is positioned, and the cap is joined to form a single airtight unit. This tiny structure must withstand pressure, prevent leakage, and ensure stable conductivity throughout the battery's life. Once assembled, the completed bottom seals tumble gently into trays, ready to be installed into each battery can later in the process. With the bottom components prepared, the battery can now receive two elements that are essential for its chemistry: the separator tube and the liquid electrolyte. First, thousands of tiny white separator sleeves, made from a special porous material, are sorted and guided onto a rotating carousel. Each sleeve is carefully pressed into the empty steel can, forming an insulating barrier that prevents the zinc anode from touching the manganese dioxide cathode. Next, the cans move to the electrolyte filling station. Here, precise pumps deliver a measured dose of potassium hydroxide solution into every battery. The process takes place under controlled vacuum conditions, ensuring the liquid is fully absorbed into the separator and eliminating air pockets that could affect performance. As the gauge drops below zero, the electrolyte is pulled deep into the material, preparing the cell for the chemical reactions that will soon generate power. By the time the cans leave this stage, they are no longer just empty shells. They are becoming true electrochemical devices. With the separator and electrolyte in place, the battery is finally ready to receive its main source of power, the manganese dioxide cathode. This fine charcoal-colored powder is carefully blended with additives to ensure stability and long-lasting discharge. Automated machines press the mixture into compact pellets or inject it directly into each steel can, forming the dense cathode layer that lines the inside of the cell. Next, the previously assembled bottom seal unit is inserted. A high-speed carousel positions each battery under a series of crimping heads, which fold and curl the steel rim tightly around the seal. This mechanical closure locks the internal chemistry inside and ensures the battery remains leak-proof for years. Once sealed, the batteries roll onto inspection trays, forming perfect grids of silver cylinders. They then move to the labeling station, where colorful heat-shrink sleeves are applied and tightened to form the familiar branded exterior. Finally, the finished batteries are packed into trays to cool and stabilize before shipping. From raw metal and powder, they have transformed into reliable power sources ready for everyday use. Asterisk. From raw steel and mineral powders to precise chemistry and high-speed engineering, the battery is a reminder that even the smallest objects in our homes contain remarkable craftsmanship. These tiny power cells quietly support our tools, our memories, and the everyday moments we often take for granted. If you enjoyed this journey through the world of manufacturing, don't forget to like this video, subscribe to D-Machine, and join us again as we explore more incredible processes behind the machines that shape our world.